I'm Andrea Griffin, and I'll be giving a talk on Wolfram Tech on online courses. Okay, so my name is Andrea Griffin. Today I'm going to talk about Wolfram Tech in online course platforms. So the first question you might have is what all that means and why I'm here. So first of all, I'm going to introduce a publicly available course that details everything that I'm going through here. So at some point I'll show you a link and you can follow along if you want to. So first, what brought me here? Growing up, I learned that I thought I might really like to teach, and I really liked math. And so I became a high school math teacher. I didn't quite like that experience. But one of the main reasons why I didn't is because I felt like there was more I could do, and I didn't have the technology to help me do that. And so I left that profession, and I wanted to help teachers teach by building educational tools. So help learners learn and help teachers teach. And so I went and got a master's in computer science. And after I received my master's, I attended Wolfram Summer School. And this is when I learned most about the Wolfram language and became really interested in the power of the Wolfram language and excited about using it. And so my goal really changed to building some tools using the power of the Wolfram language. I became a Wolfram employee, and I helped run the Wolfram summer programs, Wolfram summer camps and summer school, and a camp in Australia. And I'm still a part-time employee at Wolfram, and I still help with those programs. But as a part of being a Wolfram employee at these programs, I met a lot of people, and one of the people I met knew some professors that were looking for tools to be built. And so he hired me as a MIT employee, and so I've been spending the past couple of years making tools for educators at MIT. So before I go on any further, I just want to see by a show of hands, if I just keep talking about LMS and learning management systems, how many of you are familiar with that term? Okay. And how about LTI? Okay, much less. That's what I expected. So a learning management system, you all kind of know, is something like edX, Coursera, Moodle, Blackboard, Canvas. If you've been to a college recently, a lot of them are using them. They are basically ways that they can present instruction. They might have forms of discussion and assessment, which means most of them have a grade book, and that's kind of important in this discussion. So if I want to create tools and have them be used in the classroom, those tools need to be able to communicate with these LMS systems that are being used in the classrooms. And that's where LTI comes in. LTI is Learning Tools Interoperability, and the premise of LTI is that it's a standard that people that are making educational tools can follow and know that the LMSs will understand what those things are talking about. So LTI is a standard for like identifying users that come to that the LMS, and it also helps with the tool communicate with the gradebook. So if I was going to meet my goal to help learners learn and teachers teach, and I wanted to use the Wolfram language, I need to know that the LMS is going to be able to communicate with my tools. And so I needed a Wolfram language LTI translator. I needed to be able to use the Wolfram language following the LTI standards so that it can communicate properly with the LMS systems. And so that's what we did at MIT, and now I'm creating a bunch of tools for educators there that talk to the systems that they're already using. So that's what brought me here. Last year, I talked about that package that connected the Wolfram language to the LMS, and that talk is online and recorded, and so I didn't want to redo this talk, but you can go back and get some more information about some of the things I might skip through this time around, and that's just on the Tech Conference website. So last year what I talked about was a couple of projects that I worked on at MIT, an artifact generator and a gallery generator. And then I'm also a part of a research study where we're studying, I'll go into the details of that later. And then I also walked through the functions within the LTI package that we created. And so some of these functions identify users, like their role, if they're an administrator or a student, their email address, a hashed ID. It identifies course information, so where within the course you may be. It will send grades back to the gradebook within the LMS system. And Wolfram forms are a little more complicated to make LTI compliant. And so we also created a function that makes those forms LTI compliant. So you can use a Wolfram form in your classroom, ask students questions, and it will know what they answer. You could include a grader, and then send that grade back to the gradebook. So what's new since last year, we spent this year finishing up projects and creating more documentation and guides for that package that I had talked about last year. And so that's pretty much what we're going to go through today, is just the documentation. And then we also created something that I think is the most interesting of this talk, which is a way for students to code in a notebook on the LMS and be graded and send that information back. So we'll get to that in a second. So if any of you would like to, this is the link. I've left it up for a minute, but I'm gonna leave and go to that course. It's much smaller up there. So this course is to specifically talk about Wolfram LTI tools and how to develop them. And it also lists the tools that I've made. So we talk about how to get anything Wolfram into your course. So if you make a manipulate, how you can have that show up in your LMS or anything like that. We talk about what Wolfram is, and I don't need to go through that with all of you because you know what manipulates are when I say that. And if you don't, you'll learn more here. And then we also talk about what LTI is, how to add LTI tools into your course. We talk about the couple of projects that we had already finished and how you can just by click button add those projects to your own course for your own use. And then this is the tool we've been using for the research study, which we'll go into a little bit later. And then this is the documentation for how to make your own Wolfram LTI compliant tools and add them to your course. And so some of these functions, like getting the student's email address and information on how to save what they might submit in a form or something like that, are all in here. So I'm going to just quickly go through some of those things. So adding Wolfram to your course is very simple. You can make a cloud object. There's many, many ways to do that. And then generate an iframe by using embed code. And then you can put that iframe straight into your course. Most LMSs support iframes. And all of that information on how to do each of those steps is within this course. So if you do go here later, you can learn more there. There are also steps specifically for edX because that's what we use at MIT, but this should easily switch over to any other LMSs because that's what LTI is for. So making your course Wolfram LTI compliant, basically the main step here is you have to add an LTI passport to your course, and these are the steps to find that in edX. This is how you would add a Wolfram LTI tool to your course, and it's pretty simple, although these images aren't showing up right now. Okay, and this is one of the projects that I worked on last year. It was a gallery generator, so this instructor wanted their students to, she wanted to give them a prompt and they would fill in certain answers and submit an image, and that would generate a gallery tile. And in the end, she wanted all of the students' gallery titles to show up. Oh, I can't see there we go. To show up in a gallery all together. So this is an example of what that might look like. And so we made this last year, and I had presented on it. But this year, what we added was a tool installer. So anytime we now make an LTI tool, a tool out of Wolfram Language, we have this installer where you can fill in your Wolfram LTI passport and make your own copy of this notebook. And when you click on this button down here, it will add that tool to your own cloud so you can use it in your own course and give you instructions on how to add it to your course. Another project that we worked on last year was a Workplan Generator. So this is another tool you can just add to your course. This is having the students reflect on why they joined the course, what they might do there, and stuff like that. And then it generates a printout so that they can put it on their desk and remind themselves. And it's also a great way for teachers to understand why students took the course. This is actually the code that I've been using to do our research study. So this is all here and available to you if you'd like to use it. It's not as well built out as those other ones. It's not just a click and add, but we're working on that to get there. Okay, and so this is how you can make a Wolfram LTI tool. So to make just to take a manipulate and add it to a course, you just need to cloud deploy it and then make an iframe out of it and add that to your course. A Wolfram LTI tool is almost just as easy, so you just need to cloud deploy a delayed object that gets our package, and now you'll have all of the functions that you need to do certain things like identify the student and save their work in specific places. And so this is the bulk of what all of the tools look like. And then you would just take this URL and put it into your course. So here are some functions in the package. I'm not going to go through all of them because that's in my talk from last year, but this one just makes sure that the students actually signed in. This one gets their user ID, so you can see here is an example of it working. This is my specific user ID for this course, and so you can identify the student, maybe save their answers to a forum discussion in there based on their ID. Let me pick a good one. This one gets roles, so you can see here that I'm currently logged in as a student in this particular course, but if I go up to the top and change to a staff member, oh, it goes back to that other page. That's an edX thing. If I change to a staff member now, it knows that I'm an administrator. And this is good because if you make a tool and you want the administrators to see all of the student submissions, but you only want the student to see their own submission, you can make that you can make the tool run differently based on who's looking at it. Okay, and then this is the big one. So if you're curious how you might grade a student on something and then send it to the gradebook, well, it's just LTI send grade. So right here you can see LTI send grade 1, and then these are a part of your passport that you set up to make your course LTI compliant. It's just 2 strings that you have to know for that course. And so this is going to send a grade of 1, and you can see down here I've run this before, so it changed my grade for this section of the course to 1. Okay. So these are some examples of how you can use forms to do these things. So you can see here my grade is 0.154. This form allows the student to just change their grade to whatever they want it to be. So I'll just say 0.81. I'm not that great, but I'm pretty good. And if I refresh this course, you can now see that the grade got changed. And that just, all that was a Wolfram form. So if you're familiar with Wolfram forms, this is pretty simple. That gets the package and then does the LTI send grade with that chosen grade. And then we just needed to make an LTI tool URL for that object. So this is the URL for the form, and this is just launches the form as an LTI compliant form. Okay, so this is the big kahuna of this talk. We finally cracked this, and we'll be using it in the spring, I believe. So this is a Wolfram notebook directly in a course that a learner could go to. And again, we've given them the power to just choose whichever grade they want by setting X equal to that number. So you can see here my grade is currently 0.5 out of 1. I want it to be perfect. So I'll set X equal to that number, and then I can hit submit for grading. It says that it updated it here. It did update the grade, but these are not, they don't update dynamically. So again, I have to refresh the page, and you can see there that it changed to 1. And so what this, and I changed to the staff view, so I've changed. And so this is a really simple example, but you can add any type of grading criteria. So you could make a notebook, ask your students to do certain coding things within that notebook, look through the notebook to see what they've done, grade them on that task, and then it will automatically be sent to the gradebook, and it's all within the LMS that they normally work in without taking them outside of it. And so this is the code that did that. So this is the notebook that you saw originally. This is the grading criteria. It just checks to see if it's a number or not, and then if it is, leave it that way. Otherwise, give them a 0. So if I change this X to like A, it will change my grade to 0. And again, it's just launch notebook with some identifiers for the LTI information, and that's it for that. So those are some of the new things from last year. The other thing that happened that we've finished from last year, we were conducting this research study that I've kind of touched upon. I'm going to quickly hand it off to my colleague Kyle, who couldn't make it this year, but he talks really nicely about this thing.
So you can also change the height.
So first he's talking about manipulates, which you're all familiar with.
And notice that does not change the horizontal position of the collision, so the initial height of the throw is not an important variable.
So this is what we're hoping to engage students in, and this is not the first time we've tried to engage students with interactive widgets. But this is the first time where I'm trying to understand what about that is actually engaging, and does it in fact lead to better outcomes. So the two hypotheses that, or the two things that feed my hypothesis are that in the 1940s, there was this amazing study where they just put some shapes on a screen and then had them move around in a little video, and people anthropomorphized. They gave them human emotions and human attributes. And then I'll talk about this one in a second. So I'll let you watch this and see if just by movement, you can give some sort of story to what's happening here. So by this point, people usually don't like the big triangle. And this is an amazingly universal response. You can test it with children and adults and different cultures. And it's very clear that this triangle is intimidating and bullying the smaller triangle. And that's not actually what's happening. These are literally just shapes moving on a screen, but we've given this entire emotional story to it. So just by movement, we can engage the emotional system. We can engage the human narrative system in understanding what's happening. So yeah, you get a little celebration once they get out. So the next thing, and this is really great timing. So This is a Prakash child. So my colleague Pawan has just talked about a child who has vision restored. They were congenitally blind, and then their vision was restored later. And we want to understand how the brain starts to interpret information now that it has visual stuff coming through. And so this is a child who's been asked to identify the shape on the screen. So yes, what shape do you see? And the kid says, I can't make it out. And then you start to move the triangle. And now the triangle has become this emergent object. So instead of just giving people these static images, okay. Instead of giving people just static images, we want them to engage in movement so that we can get that kind of visual learning process, that mapping of physical phenomenon onto the visual cortex. Especially at MIT right now, we have Mary throwing these balls during a talk. So if we return to our question, we have Mary throwing these balls, and there's this tension, especially at MIT right now, about how do I engage students in doing this type of work. I can have them do math by hand. We think that there's definitely some value in that. I can have them solve it using a computer algebra system, or just coding it, computer programming. Or I can have them interact with a widget and have them play with this thing and learn visually. And these are three equivalently engaging ways to learn for different people. And we want to know which one and how to give different learners so that they engage.
So that's kind of the premise of the study that we were working on, and it was somewhat impossible to make this study happen without some of the technology that we had developed. And one of the reasons is because we did a 2x2 factorial design where each student that took the course, they were a part of a specific group, and this is the breakdown of the groups. They got either an interactive widget or coding instruction or not. And the LMS systems have A/B testing and that kind of thing, but we wanted to make sure that every group was equally separated so that there wasn't all physics experts in the first group and all physics experts in the fourth group, and then none of the other ones knew anything about the topic at hand. And so we finally, so using the LTI system, we were able to ask them questions up front, grade their work, and place them into certain groups using a clinical trial algorithm in real time. And so the results of our study came through, and what happened is we didn't have enough participation in each of the groups to come up with any results. So I know you're really hoping to hear about if these interactive visual widgets help with learning, but we don't know the answer yet. And but we did come up with this tech stack, and I'm running out of time, so I won't send that through, but the tech is what allowed us to be able to even run the study in the first place. So what's next? We've changed the premise of our study. We were looking at both visual widgets and coding and how that changes how students learn in the classroom. And we've changed our premise to now just looking at the visual widgets, which allowed us to break it down into 2 groups instead of 5. And then we're also adding coding instruction into the residential version of this class because this is an online class. And so we could, in 2020, we should be able to then take that coding instruction and incorporate it into the study. As a part of the study, we also asked students questions using a manipulate. So we gave them a manipulate and said, move the slider to a certain point that represents the answer to this question. And we were able to use that. The course actually just ended like yesterday. So we were able to use that in our pre and post testing, but I don't have that quite yet built into the LTI package, so that should be coming soon. We're also creating computational labs for a multivariable calculus class, where we'll be using that launch notebook thing that grades the students. So we haven't quite used that yet, but hopefully next year we'll be able to talk about that. And then I also am just working on a phase diagram explorer for the material science department, so if any of you are interested in that, we can talk about that later. And that's all I have for today.